Hello everyone and welcome to the first video of the mathematics playlist of Minute MYP. Today we're going to start with an extended mathematics topic called logarithms, and we're going to talk about logarithms, the rules of logarithms and natural logarithms. So let's get started. The first thing we're going to talk about is the general form of logarithms. Logarithms have the general form of log a b is equal to c. Let's define all the terms. So this is just the log function. This is the base and this is the argument. Whenever you're talking about this log equation, or you're writing an explanation, or even in your mind, just to be clear, this is how you're supposed to think about it. Now this base form is going to be modified in any kind of logarithm. So maybe you'll see maybe in the bracket you'll have not just b but maybe 2b or b plus something, but it's all going to revolve around this base form. Now let's talk about the laws. So this base form gives us one law first. It's the law in which you can change an exponential equation to a logarithm and you can change it vice versa. What I mean over here is that let's say you have an exponential logarithmic equation log 3 5 is equal to this. So now using the transformation of exponent to logarithmic statements, we can do a cool thing and we can write it as 3 to the power of 1.465 is equal to, my bad, is equal to 5. So we can write this. Now basically what we did in the law form would be log AB is equal to C can be written as A to the power of C is equal to B. So just take a look at that. Basically, I'll just make this a little clearer. Okay, log A, remember A should always be in the subscript. So log AB is equal to C, and you can write A to the power C is equal to B. So just, this is a very neat thing, because let's say you have, instead of having this first and this second, you now have this given to you and you have to convert it into this. Now you can just know that it will be A to the power C is equal to B in this form. So where A would be 3, B would be 5, and C would be 1.465. And then you can just use the base form of a logarithmic equation to convert it back. So that's the first important law you need to know. Now, moving on with the second law is called the product law. So the next few laws, which is the product laws, the quotient laws, and those are extremely simple, and I'll just go through them really quickly. So first of all, you have log, let's say, actually I should rather write the name first. This is called the product law of logarithms. Now let's say you have log 3 plus log 5. and you have to simplify this without a calculator. What you're going to write down is obviously going to be an answer in log, but what can you do with this? So now think about it like this. You know, in fractions, when you have the common denominator, you can simply add the two numerators together, like 2 by 3 plus 1 by 3 becomes 3 by 3. Similarly, the denominator in this case would be the base. Notice how I've not written the base, I've only written the arguments. This is because if it's not written, that means that the bases are the same or they're going to be 10. So usually I'll write this as a key point over here. So if it's not mentioned, if not mentioned or explicitly written, it is by default going to be log with the base of 10. The base will be 10. So that's just some information for you. But even if they have another base like 4, 5, 6, as long as the two logs have the same bases in the subscript, you can apply this rule. And this rule states that if they have the same bases, the arguments, when the two logs of the same bases are added, are multiplied. So log 3 plus log 5 will be equal to log of 3 times 5, which is equal to log 15. That is the product rule. So log, um, so we're going to write as log a plus log b is equal to log a b. That's the rule. Now let's go to the third law, which is going to be the quotient law, because logically if we have a law for product, we're going to have a law for quotient, which is with division. So this is also fairly straightforward, because if you have, let's say, log, shall we say 20, and then you're going to from this you're going to minus log 5, and sorry, I wrote in the base. These two laws, I should probably write that down. These two laws, which involve two separate logarithms, they need the logs to have the same base. That's key here. So basically log 20 minus log 5, if they have the same base, is going to be equal to log 20 upon 5, which is going to be equal to log 4. So basically you have the rule of log a minus log b with the same base is equal to log a upon b, and of course vice versa. And a key trick here is that when you have to simplify logarithms, you can often break it up. Meaning that if you have something that, like maybe you have already log 4, you can split it up into log 20 and 5, for example, log 20 minus log 5 if you need, for example. Or if you have log 15, you can break it up and write it as log 3 and log 5. So if you need in the question, you can break it down. That's a key point that you should be remembering. So it applies both ways. The next law that we are going to talk about now is the power law. We are going to exponents. So exponent power law. So this law is honestly one of the laws that is used the most, and I mean the most. And it's extremely convenient because it literally creates a coefficient out of an exponent. So this is one of the most useful laws for simplification that I have personally ever used, and that comes with a lot of questions. So let's see. Now, if we have, for example, log, shall we say 3 to the power of 1 by 4. Now, what do we do with this? You see that we have an exponent power of 1 by 4. So this exponent actually can just get moved right here and become a coefficient of the entire log. So log 3 to the power 1 by 4 can be written as 1 by 4 log 3. It just got shifted from here down to here. It's that simple. That's literally just it. If you have an exponent on a log, you can just shift it to the front of the log, and if you have it in the front of the log, like you multiply it, if you multiply 1 by 4 times log 3, you can write it as log 3 to the power 1 by 4. And why this is really important is because if you have something like 1 by 2 times log 9, let's say the base is 3. Now, what's really key here is that you might be thinking the base is not 10, and there's an x and there's a coefficient, and what do we do here? What you can do here is you can simplify this into such a simple answer using this law and the next law I'm going to talk about. So let's cover what the part of this law is first. In this law, what's going to happen is that since we know that a exponent can go to a coefficient can also become the exponent again. So you can rewrite this as log 3 times 9 to the power of 1 by 2. This 1 by 2 just got shifted up there. And 9 to the power of 1 by 2 basically is root 9. And root 9 is going to be equal to log 3 and of root 9, and root 9 is 3. So you have log of 3 of 3. That's the exponent power law. Log a b to the power c, where c is an exponent, is equal to c log a b. Basically, that's what you have. Now, moving on to the other law, let's just carry on the simplification that we were doing with the log 3 from here. So we're just going to bring this down, and this is log when base is equal to the argument. In this one, you're going to have that if you have the same base and the same argument, meaning that a, which is the base, is equal to the argument b, you simply get 1 is the answer. Yeah, that's just it, 1. So log 3 of 3, for example, you have the same base and the same argument, 3 and 3. This can just be written as plain sweet 1. That's it. And this is extremely good for simplification because you can just remove an entire log and get 1. So that's it. So log a of b, where a is equal to b, is equal to 1. That's the next law. And similarly to this one, you have log of 1. This just remember this, guys, is extremely simple. Whenever you have log of a of 1, doesn't matter what the value of a is, 5, 6, 7, 10, 99, it doesn't matter. Log of 1, where 1 is the argument, will always give the answer of 0. So you have log of a1. Yeah, I just wrote that already, so sorry, my bad. So log a of 1 is just going to be equal to 0. So a log of 1 is just 0. And now we have the final important formula called the change of base formula. This is really, really important for this reason. Remember how I told you earlier that these two key laws, 2 and 3 over here, apply only when there's the same base? What if you need to apply those laws but it doesn't have the same base? You can convert a log into any base you want, literally any base you want. So you can apply these rules. That's one of the coolest parts of log. You can literally make the simplification, you can force it to simplify. And this is how you do that, just by remembering this small rule. It is that if you have, let's say, log 2 of 9, but you don't want the base to be 2, you want it to be, let's say, 3. What you can do is that you can write down log base 3 upon log base 3, which is the base that you want now, and simply write 9 upon 2. So now you have log 3 9 upon log 3 2. And if you simplify this particular expression further from the power rule we learned earlier and the log when base is equal to argument, you can write 9 as log 3 3 square upon log 3 2, and we know that 2 basically is can go to the coefficient, and log 3 of 3 is 1, so you just get the final answer of 2 upon log 3 2. We notice how we just simplified that and we got to a base that we want. So if you can write log ab is equal to log, and I mean, it doesn't, you don't have to change the base with this rule. You can just write it as a fraction as well if you need to. So basically you can just write log ab is equal to log b upon log a, and if you want to insert any base you want over here, you can if you need to. And that's about it for logarithms. Those are all the important things you need to know. These 7 rules. And in the next video, we are going to talk about natural logarithms. Thank you for watching.